Okay, as we wrap up our module here before Thanksgiving, we're going to finish up with using the derivative for economic situations in business, dealing with profit and cost and loss and revenue. But our model idea stays the same. We want to look for the goal. We want to identify the variables that we need to achieve that goal and write an equation. And then we'll use the calculus after that. All right, so let's just practice with a generic question. So 2 unknown non-negative numbers have a sum of 20. All right, so let's say x plus y equals 20. Their product is what we want to find the maximum of. All right, so number 1, our goal. Our goal is the product. That's the noun that we're looking for, what we're supposed to find. It will be a maximum. 2, our variables. Right now our variables are x and y, but having 2 variables in different terms is problematic. And so if we could get one of the variables by itself, that would be helpful. And so I'm going to choose to get y by itself. And so when I do that, y is 20 minus x. So my 2 variables are x and 20 minus x. So then my equation, instead of being x times y, my equation is going to be x times 20 minus x. That's the product. Now I need to find the critical points of this. And so I'll find the derivative, which would be 20 minus 2x. I'll set that equal to 0. So x is 10. And if x is 10, y is 20 minus 10, so that's also 10. Now without a graph, how can I confirm that this is going to be a maximum? So I'm going to use the second derivative test. Since I don't have a graph to look at, I'll use the second derivative test. So f double prime is -2. That means this function has negative concavity. Okay, so that implies negative concavity. The second derivative test tells me that if a critical point has a first derivative that's equal to 0 and a second derivative that is negative, then that's a max. So the second derivative test confirms that it's a max. And then the question, have I answered, well that was 6. Okay, and then 7, did I actually answer the question? And the question is, find the maximum product. So that would be x times y, or 10 times 10, or 100. So this was an algebraic question tied in with some geometry. Now let's go on to some business questions. Just a few definitions you need, some variables that you'll need in terms you'll need to understand. The profit function is the difference between revenue and cost. So in mathematical terms, P of x equals R of x minus C of x. Okay, so suppose that the revenue function is 9x and the cost function is x cubed minus 6x squared plus 15x, where x represents thousands of units. Is there a level that maximizes the product, the profit, and if so, what is it? So our goal is profit, and specifically the maximum of the profit. Our variables that will achieve that are revenue and cost, which we're given. Our equation is P p of x equals the r of x, which is 9x, minus the cost, so x cubed minus 6x squared plus 15x. We distribute the negative, and then that will simplify to negative x to the third plus 6x squared minus 6x. All right, we want to this time probably use our calculator, and we'll put this into our y1, and then we want to find p prime and set that equal to 0. Now I can do it with my calculator, or I can do it by hand. Now this doesn't factor very well, so I'm going to suggest that we graph this. And when we look at a graph of this derivative function, we see an upside down parabola. So there are two critical points, and we want to make sure that we choose the critical point that would give us a maximum. And so our maximum would be the one where it's crossing from positive to negative. And so we end up with that critical point being 3.414. Now remember, that represents thousands of units. So this is 3,414 units that would produce the maximum. I'll use the second derivative test to guarantee that it's a max. So my p double prime is negative 6x plus 12. And at this value of 3.414, p double prime of 3.414 does turn out to be for sure a negative number. And so since it is a negative number, the concavity is down, and so that confirms that this would be a max. So we've confirmed that it is a max. And then have we answered the question? So is there a production level? So yes. The max profit occurs at 3,414 units. Another definition that you will find helpful is the definition of average cost. So the average cost, called C of x, is the ratio between the cost and x. Now, average cost is denoted by a little bar above the C. That's how we know that referencing. So we know prime means derivative, bar means, so we say C bar. That is definition of average. So when we write that out, C bar is C of x over x. Okay, the ratio, which means the division between C of x and x. Okay, so suppose we have the same revenue and cost functions that we had before. Is there a production level that minimizes the average cost? So our goal is average cost, or C bar. Our variables are C of x and x. Our equation, C bar of x is x cubed minus 6x squared plus 15x, all divided by x. Now that reduces very nicely. So C bar reduces to x squared minus 6x plus 15. All right, now we're ready for the calculus of this. So we want to find C bar prime, which is 2x minus 6, which is pretty easy to solve. So x is 3. Now, how can we make sure that we have a, what kind of, if this is a min, or if this is a max? Well, we want to check second derivative, so c bar double prime. And c bar double prime is just 2, which means that is greater than 0, which means it's concave up. And so the second derivative test confirms that it is a minimum. And so have we answered the question? Is there a production level? Yes, the production level is 3, but remember that 3 is representing 3,000. Okay. So the minimum average cost occurs at 3,000 units. All right, so the good news is that on Thursday when we get together, we have nothing to do, no new lessons to learn going into Thanksgiving. We just have the day to spend to work on these problems together. So mostly it's going to be the setup part of it, not the calculus necessarily. All right, so take heart. We don't have anything new to learn, and we'll spend Thursday plugging away and diagnosing some of the difficulties you may have had in some of the problems. But use friends, okay? Reach out to people. Collective wisdom is always better than trying to do it on your own. All right, I will see you on Thursday.